Hey, welcome to Math. Mr. Jorgens here. Going to start chapter 8 for the Ed Puzzles today. 8.1 Graphing Quadratics. It's related to the stuff on parabolas. So when we see the word quadratics, the graph of those, we kind of call them parabolas. Those U-shaped graphs we were looking at on the Desmos is what we're talking about here. This is going to be a part 1, and we're going to continue with it next week. All right? So stay tuned for learning here, and there'll be a few questions for you to answer along the way, so make sure you're paying attention. All right, from last time, we have a few notes to take down that are really important for us to know about. The first thing is whenever we're talking about these things, we're talking about parabolas, right? So this is our name of these graphs. They look like a U shape, right? And we kind of looked at some different ones last time, and you worked on the language by practicing with a partner. And when we did that, there were a few terms that kind of came out of there. The first one is we said that graphs like this, or like this, or like this, all open up. So we'd say the parabola opens up if it looks like that. The opposite, if we were doing this, or this, or this, we would say the parabola opens down, right? So that's some language we need to be able to use. We also use the phrase concave up and concave down. So concave is kind of like the big word there. So opens up, we could say concave up. For opening down, we could say concave down. The other thing we kind of talked about is when we looked at a parabola. So let's say this is our parabola. We talked a lot about the turnaround point, so this point right here. And again, during that activity, we were calling it the turnaround point. From now on, we're going to call that point the vertex. So again, that turnaround point, we call it the vertex. And then the other thing we talked a little bit about, or hopefully we thought a little bit about, and I saw you guys describing it to each other, and then part 2 of that activity, I think there's one screen where we talked about this. It came a little bit less, but if you have a parabola like this, the y-intercept is where it crosses the y-axis, and there will be one of those, right? So that's the y-intercept. And the x-intercept is going to be the spots where it crosses the x-axis, right? And there could be 2 of those, and we could also have 1 or 0, and we'll talk about that as we go throughout the chapter. But those are the x-intercepts. So that's just kind of some of the language we wrote down from last time. Hopefully we're comfortable talking about things that are on this screen here. All right, so our first real problem where we're going to have to do some calculations in this chapter is example 1. We're going to graph y equals x squared, and we're going to use a table of values in order to do that. And we've kind of talked about this before, but in math, whenever you're trying to graph an equation or a function that you have never seen really before, usually the best way to start to do that is to pick a table. And so picking a table, what I mean by that, of course, is setting an x, y coordinate pairs here. And what you do is you just pick some x's, and usually it's a good idea to pick 0, a couple positives, a couple negatives just to start with. And then if there's a part of the graph that's unclear where it's going to go, then pick a couple new values where it's unclear where it's going to go. And then what I'm going to do is I'm just going to evaluate that equation for each x. So for example, I'll start with -2. So y equals -2 squared. And -2 squared means -2 times -2. -2 times -2 is a positive 4, right? And then we just do it again for the next one. So -1. So y equals -1 squared, which is -1 times -1, which is positive 1. And then the next one, y equals 0 squared, which is 0 times 0, which is just 0. 1 squared, 1 times 1 is 1. And then the last one, plug in 2 for x and tell me what the y would be. So plug in 2, evaluate the function for y. Essentially, I'm looking for the number that I'm going to put right here. Go ahead and enter your answer when you're ready. Yeah, it's going to be 4. 2 times 2 is 4. And that gives me my table of values. So once I have my table of values, I'm going to be able to go through and plot some points, right? And so starting with the first one, -2 and 4, that means 2 spaces to the left and 4 spaces up, which would put that point right there. My second point is -1 and 1, so that's 1 space to the left, 1 space up. My third point is 0 and 0, which is the origin or that center kind of point on the graph. My fourth point is 1 and 1, so right 1 and up 1. And hopefully after practicing plotting some points today, we're feeling comfortable with that. 2 to the right, 4 up. That's our fifth point. So I have my 5 points there. And once I have my 5 points, I can go ahead and draw my parabola. And it's going to be U-shaped, right? So as I draw my graph, I'm going to try to make kind of a smooth curve there. Through the points. All right, so we kind of built out this parabola. Now my last question for you before we move on is this parabola, does it open up or does it open down? So go ahead and enter that answer when you're ready. All right, our second example here, we're going to graph y equals 3x squared. And again, we're going to do that with the table. All right, so I'm going to set up my table of values there. My graph is going to be there to the left. And again, whenever I'm not quite sure what it looks like, pick a few positives, a few negatives, and 0. So I'll pick the same values I did last time. That's usually a good starting spot to try. 1 and 2, -1 and -2, and 0. And then I'm going to plug in my values and evaluate that equation at those values. So starting with -2, I'd have y equals 3 times a -2 squared. And I'm doing PEMDAS here, so I have to do exponents first. So exponents first would give me -2 squared is -2 times -2, that makes 4. And 3 times 4, that makes 12. And -1 would be 3 times -1 squared. Again, I got to do the exponent first, so -1 squared is 1. And 3 times 1 is 3. Then same thing here, 0, so 3 times 0 squared. 3 times 0 is 0, because 0 squared is just 0. Again, if I do it again for 1, it would be 3 times 1 squared. 1 squared is 1. 3 times 1 is 3. So hopefully the evaluating kind of made some sense. Go ahead and find that last y value. So plug in 2 for x and find the y. And find that number that goes in the green box and enter your answer when you're ready. Yeah, hopefully you got 12 again for that one. And that kind of sets up our table of values here. So all these problems have 2 steps. The first is to evaluate the functions to find the table of values, and the second is to plot the points. So the first point is -2 and 12, so 2 spaces to the left, 12 spaces up is going to put us all the way up. I counted this graph out ahead of time to make sure it was 12 spaces up. And then the second point is going to be -1 and 3, so 1 to the left and 3 up, put us right there. And then the third point, 0 and 0, is the origin, so right at the middle. And then the fourth point is 1 and 3. So 1 to the right and 3 spaces up. And our last point is 2 and 12, which is 2 to the right and all 12 spaces up. Then once I have those points on there, I can draw a smooth curve through my points here. And you'll notice that this graph is what we call stretched. It's much narrower because the points got stretched up, right, from the example 1 graph. So since the points got stretched up, the graph appears much less wide or much more narrow than the first graph. All right, so hopefully you noticed that this graph had some slightly different properties. And we're going to look at one more graph today. All right, we're graphing y equals negative 2x squared with the table. So I'm going to put my grid on here for you guys. All right, so we have that graph set up. Same thing, we're going to input some values here into our function and evaluate it for those x's. Figure out what the y's are, then we're going to put the points on the graph and draw our smooth curve. So I'm going to start by inputting negative 2 and work my way up. So when I input negative 2 for x, I get y equals negative 2 times negative 2 squared. And the negative 2 squared is 4, so negative 2 times 4 makes negative 8. Then I'm going to input a negative 1, so negative 2 times negative 1 squared. Again, I'm doing exponent before multiplication, PEMDAS, right? So I do e first. Negative 1 times negative 1 makes 1. So then negative 2 times 1 makes negative 2. I'm going to do 0, so negative 2 times 0 squared is negative 2 times 0, which is 0. Hopefully you notice that every time we do 0, we end up at the origin, because when I plug in 0, it makes 0, and then 0 multiplied by anything is still 0. Then I'm going to plug in 1, so negative 2 times a 1 squared is negative 2 times 1, which is negative 2. And I'll let you fill in that last box down here. Go ahead and input negative 2 into the equation and figure out the output for y. Enter your answer when you're ready. So plug it in 2, got negative 8 here. All right, so I'm going to go ahead and put those points on the graph, same way that we have been, and then draw our smooth curve. From the top, negative 2 and negative 8 is 2 to the left and 8 down. So that yellow point right there. Then negative 1 and negative 2 is 1 to the left and 2 down. And then 0 and 0 is right in the middle. And 1 and negative 2 is 1 to the right and 2 down. And 2 and negative 8 is 2 to the right and 8 down. And then we're going to draw our smooth curve through here. And that graph will do it for us. Last question of the day is whether this parabola opens up or opens down. So answer that one, enter your answer when you're ready, and then have a good day.